Okay, so good morning to one and all. In the previous practical, we have discussed about the one practical is that uh, speed control of DC shunt motor by using armature control method and by using a flux control method, or we can call it as a field control method. So this experiment we have already covered in the previous lecture. That is experiment number 2. Now today we will discuss about the next one experiment is that the load test on DC shunt motor or determination of efficiency and speed regulation of a DC shunt motor by using a direct loading test or by conducting a direct loading test. Okay, so this experiment we want to take today. So see the title of this experiment is that experiment number 3, determination of efficiency and speed regulation of DC shunt motor by direct loading arrangement. As we people know that the load on the DC shunt motor, it is in the form of mechanical. So we are directly putting on the output of the motor, that is mechanical load on that motor. त्या मोटरवरती आपण mechanical load काय करणार, put करणार. So this is the direct loading condition. So direct loading and indirect loading we will discuss in case of our unit number 3, that is testing of DC motor or testing of DC machine. In that we will discuss. But direct loading is nothing but output of the DC shunt motor. It is in the form of mechanical. So we are directly putting a mechanical load on that machine. त्या machine वरती आपण काय करतो, mechanical load put करतो. So this is the title. Now aim of this experiment is that the determination of efficiency and speed regulation of DC shunt motor by using direct loading. Apparatus required for that, त्याच्यासाठी लागणारे जे काही apparatus आहेत. So apparatus required for that is nothing but we required one voltmeter to measure the supply voltage having a range 0 to 300 volt. Second one, we required ammeter to measure the supply current, or it may be load current having an value 0 to 10 ampere, or it may be, it is depends upon rating of the motor. Then we require one of the rheostat which are connected in series with that of field winding to run the machine at a rated speed, or it may be to run the machine at a rated speed condition. Okay, rated speed ला आपल्याला machine run करण्यासाठी आपण काय use करतोय, one of the rheostat, it can be connected in series with that of field winding. Now one tachometer is required to measure the speed of the machine. Machine चं जे काही speed आहे the speed measure करण्यासाठी एक आपल्याला tachometer required आहे. So one tachometer it can be required to measure the speed of DC motor. Now we will see regarding theory of that DC shunt motor direct loading. So shunt motor has a definite no load speed, hence it does not run away when load is suddenly thrown off. Okay, so provided the field circuit remains closed. If we are taking a field circuit, it is in the constant value, or it may be there is a no change in the field winding, and when we are load, it can be thrown off on that of DC motor. So the DC motor speed, what is the change in that speed, what is the change in that output, or it may be what is the change in that efficiency, we will see by taking an observation and by drawing an graph. Now the drop in speed, that means the speed of DC motor, it should be slightly drop or slightly less as compared to that of no load speed. The drop in speed from no load to full load is small, that means we can use here word slightly less than that of no load. Hence this motor is usually referred to a constant speed motor. So that this motor ji ahe, that is DC shunt motor, it can be referred as a constant speed motor. And the efficiency curve is usually of the same shape for electric motor and generator. याचा जो काही efficiency curve असेल, so this efficiency curve, it is usually same, it will be usually same for all types of electric motor, also all types of electric generator आणि motor साठी याचा जो काही curve असेल, it is similar असेल. Okay, now The shape of efficiency curve and the point of maximum efficiency can be very considerable. Efficiency जो काही कर्व आहे आपण ड्रॉ करणार आहे आउटपुट पॉवर वर्सेस efficiency. This curve and also efficiency curve and the point of maximum efficiency. Maximum efficiency चा जो काही point असेल, it can be very considerable by the design, or it is considerable thing while designing a machine. Though it is advantageous to have a efficiency curve which is fairly flat. That means efficiency जो काही curve असेल, so this efficiency curve it should be a fairly flat in shape. Flat in shape मध्ये असेल. Now, so that there is a little change in efficiency between load and 25% overload. त्याच्यामुळं त्याचा जो काही efficiency curve असेल, this efficiency curve it should be little change. There is a little change between that efficiency curve from load and 25% above that of load. त्या लोडला आणि त्याच्या 25% लोडला त्याचा efficiency curve काय असेल, फ्लॅट असेल. Okay, and have the maximum efficiency as nearer to the full load as possible. याची जी काय maximum efficiency असेल, it will be getting at near about full load condition. Now, from this curve, we are able to observe that in certain value of current is required even when output is zero. Okay, ज्यावेळेस output zero असेल, that means output zero. When the output it will be zero, output कधी zero असेल? Output कधी zero असतं? Whether load it can be putting on machine, load put केल्यानंतर zero असतं का load put करण्याच्या अगोदर? Hello?
Load put करण्याच्या अगोदर.
Right. That means before putting a load, loadच put केलेलं नाही मोटर वरती, so that motor takes a minimum load. It cannot be put on the secondary side of the motor. That means the secondary current it will not flow. जो काही secondary side चा current असेल तो flow होत नाहीये. So this current remains zero and the efficiency or the output power zero. That means current it will be zero. Current zero आहे, output power. But also motor it will be take some of the current from the supply at no load condition. Upon no load condition ला motor run केली होती, it will take some of the current. So this current it is due to that of to overcome the no load losses. No load losses जे आहेत ते overcome करण्यासाठी, that means no load losses त्याच्यामध्ये कोणते कोणते losses असतात? Hysteresis loss and eddy current loss, that means core losses, or we can call it as iron losses. To overcome these various types of losses, so motor it will take some of the input current at zero value of output. Okay, so motor input under no load condition goes to meet the various losses occurring within the machine. As compared to the other motor, a shunt motor is said to have a lowest starting torque. Other motor ला compare करता जी काही shunt motor आहे, so shunt motor it is having an lowest starting torque. त्याचा जो काही starting torque आहे, so this torque it is the lowest starting torque. Okay, lowest starting torque. Now, but this should not be taken off. This should not be taken off means that is shunt motor is incapable of starting heavy load. So याचं meaning असं नाहीये की DC shunt motor it is not a capable. That means it is capable for starting at a heavy load condition also. Actually, it means that series and compound motor are capable of starting heavy load with less excess of current input. Okay, with less excess amount of current input. So over a normal value, then the shunt motor and the consequently the depreciation on the motor will be relatively less. Motor चं जे काही depreciation असेल, so this depreciation of the motor it is relatively less in that case. Okay, so shunt motor and the consequently the depreciation on the motor will be relatively less. Now we will see regarding connection diagram or the schematic diagram of DC shunt motor, while it can be putted on load condition or the connecting a load on the top machine. See, here it is positive and negative supply. त्याच्यामध्ये बघा, this one is the positive terminal and this one is the negative terminal of the machine. Negative terminal of the power supply. We are feeding this power supply to the one 3-point starter. का 3-point starter ला feed करतोय. By using this 3-point starter, we are able to start our DC shunt motor safely. So see, one positive terminal of the supply, it can be connected to line terminal of the 3-point starter. Then field terminal of the 3-point starter, it is connected to one of the rheostat. So इथे एक rheostat use केलेला आहे बघा to run the machine at a constant speed. Then here it is field winding of the motor, and A terminal of the 3-point starter, it can be connected to A1 terminal of the motor. मोटरच्या A1 terminal ला connect केले, and A2 F2 it is short circuited. A2 आणि F2 they common आहे, and it can be connected to that of negative supply. ते परत negative supply ला connect केले. To measure the supply voltage, we are putted one voltmeter across the supply. Positive and negative च्या across एक काय केले voltmeter connect केले, and one of the ammeter it can be connected to measure the current taken by the motor at that load condition, or when the load it can be putted on the motor. Motor वरती ज्यावेळेस load put करतोय त्यावेळेसचा current as well as no load condition चा current. Now, what is mechanical loading, or it may be direct loading? The mechanical output of the motor, motorचं जे काय mechanical output आहे किंवा shaft आहे, here it is one of the drum, it can be attached, and we are that means here it is by using a brake drum arrangement, we are applying a force on that pulley, or it may be drum. या drum ला काय करतो आपण एक force apply करतो. Okay, so the force is nothing but or we can call it as a load test, or sometimes it is called as a brake test. So by applying such force, we are directly break the rotor also. Rotor काय करू शकतो आपण ब्रेक पण करू शकतो, म्हणजे रोटेट व्हायचा स्टॉप करू शकतो. Okay, so this is the highest condition of the load, or maximum condition of the load. At that condition, the motor it may be damaged also. Okay, so we are not using that much amount of load. We are using just rated current or less than rated current, it will be flow on that motor. We are putting on the such load on that of mechanical output of the motor. See, here it is done. Here it is 2 meter is there to measure the load putted. It is in the kg. Okay, S1 and S2 we are using here at watchment how much amount of load it can be putted on the motor. If we take a difference between that, so this force, if we want to convert into Newton, so Newton मध्ये convert करायचं असेल तर we are multiplying by 9.81, and this it can be converted into torque. So formula for torque is equals to S1 minus S2. That means this S1 value minus S2 value into radius of that drum. Drum ची radius किती आहे त्याच्यावरती depend राहील, into 9.81. So it can be converted into Newton. Newton मध्ये काय होईल convert. So this is the schematic diagram of performing these types of experiment. हे experiment perform करण्यासाठीची ही schematic diagram. Now, so connection procedure, connect circuit as per the circuit diagram. जशी circuit diagram आहे त्याच्यानुसार connection करायचं. Switch on the power supply. Start the motor using 3-point starter. 3-point starter चा use करून motor start करायची. Now, adjust the field rheostat to reach the motor at its rated speed. Motor rated speed la reach will. At that point, we want to adjust the rheostat and note down the no load reading of voltmeter, ammeter, and tachometer, and also note down the reading of spring balance. That means drum ला जे काय आपण load put करतोय त्याचे जे काय spring balance meter आहे, so we are taking that much reading. And now apply the load step by step. त्याच्यानंतर step by step load काय करायचं apply करायचं, and note down the corresponding reading till the rated current is reached. So these are the simple procedure. Now observation table. All of you take a screenshot of this observation table. Observation table चा screenshot घ्या सगळे. See, see, we want required the reading of voltmeter. Initially V1 चं voltmeter जो आहे त्याचं voltage reading घ्यायचं. Now we are able to take the reading of load current IL, speed of the motor, it is in R revolution per minute, spring balance constant S1 and S2. Now we are able to do the calculation, that is S1 minus S2. After that we are finding the torque of that machine. It is equals to S1 minus S2 into drum radius R into 9.81. After that we are calculating the output power. So what is the formula for calculating output power? Output power calculation साठी formula काय असतो? That is P output is equals to 2 pi NT divided by 60. 2 pi NT divided by 60. त्याच्यावरून आपण calculation करणार. After that input power it is in the form of electrical. So supply voltage V and the load current I. The product of these two is nothing but input power. And after that we are able to finding the efficiency, that is output power divided by input power. Okay, output power divided by input power, it is nothing but efficiency. So this is the observation table. All of you take screenshot for writing the observation. Now model calculation is there. Input power, it is equals to VL into IL, it is in the watt. Output power, it is equals to 2 pi NT divided by 60 watt, and the here 2 pi is the constant, N is nothing but speed of the motor, T is nothing but torque, and 60 it is constant. So we are able to calculate the torque T. It is equals to S1 minus S2 into 9.81 into R. S1 minus S2 into 9.81 into R, Newton meter, where R is the radius of drum in meter. And after that we are able to find out the efficiency, that is output power divided by input power into 100. Okay, so this is the calculation part. Model graph हे बघा, efficiency versus output power. So it will be like a flat graph, or it will show the linear relationship. As the output increases, the efficiency it will be increases, and at one point if again output increases, the efficiency remains constant. Okay, and the speed versus torque characteristics we have already we have not studied. Speed torque characteristics is nothing but the load speed, it is slightly less than that of no load speed. No load speed पेक्षा ते slightly काय असेल, less असेल. Torque versus speed characteristics. So these are the model graph, and after that final we want to write result. The load test on DC shunt motor was performed and the respective graphs were drawn. Load test on DC shunt motor was performed and the respective graphs were drawn. Okay, so these are the result it will be achieved after performing the test. Getting this theory? याच्यामध्ये कोणाला काय डाऊट आहे का theory मध्ये? Hello.
No, sir.
Okay. Now we will perform the practical. I will join by my another one device like mobile, and I will switch on that camera. So we will perform practical physically. Okay. I will stop sharing here. Hello, am I audible?
Yes, sir.
Okay. See, tell me the connection diagram. We have already explained the connection, but can anyone able to tell? काय होतं? This is the positive and negative terminal. All of you visible this one? हे दिसते का?
Yes,
Yes.
sir.
Yes, sir.
See, this is the positive terminal. We want to connect this positive terminal to the line terminal of the 3-point starter. 3-point starter च्या line terminal ला मी काय केलं? Connect केलं. Now, second one connection is that. Second one connection काय होता? सांगा.
F connected to resistance.
3-point starter चे L point ला connect केले. Now 3-point starter having another one point, that is field terminal. So I am connecting this field terminal F to that of one point of rheostat. Rheostat च्या त्याच्या अगोदर एक ammeter connect करायचं आहे ना. Okay, just 1 minute. We will directly connect positive terminal of the supply. It can be connected to the one terminal of the ammeter. Ammeter चे एका terminal ला connect करायचं, right? So we are connecting here one terminal of the ammeter. Then next terminal of the ammeter. Ammeter चे जे काही next terminal आहे, that is one of the common terminal. It can be connected to L terminal of the 3-point starter. 3-point starter चे L terminal ला connect केले, line terminal. Now next one, the field terminal F1, field terminal of the starter, it can be connected to one terminal of the rheostat. Rheostat चे एका terminal ला connect करतो. So this is the rheostat. I am just connecting here. Okay, I am connecting to the one terminal of the rheostat. Now next terminal of the rheostat, that is variable terminal of the rheostat, कुठे connect केलेलं आहे? Rheostat चं next terminal
F1 ला.
आपण कुठे कनेक्ट करतोय rheostat चं next terminal?
F1 terminal.
F1 terminal of the motor, right? No. So motor चे F1 terminal ला see, so एक variable terminal मी connect केलेलं आहे rheostat चं. This terminal, it can be connected to the F1 terminal of the motor. It can be connected to the F1 terminal of the motor. So here it is motor having a terminal F1, right? Now next one connection is that, next connection, it is nothing but armature terminal of the motor, armature terminal of the starter, that is A terminal of the starter. It can be connected to the A1 terminal of the motor. Motor चे कुठे connect करायचे? A1 terminal, right? Right now?
Yes, sir.
Now A terminal of the 3-point starter, it can be connected to A1 terminal of the motor. Motor च्या A terminal ला connect करा. Now A2 F2 it is short circuited. दोन्ही काय आहेत? Common आहेत, right? So A1 terminal, A2 and F2 of the motor, it can be short circuited. ते दोन्ही short circuited आहेत. And then one terminal, it can be connected to negative terminal. त्याचं जे काही एक टर्मिनल आहे ते दोन्ही कॉमन करून आपण कुठे कनेक्ट करतोय? It can be connected to one negative terminal of the supply. Here it is negative terminal of the supply. Now one connection is left, that is we want to use the voltmeter also. आपल्याला voltmeter use करायचे.
So we are connecting one of the voltmeter across positive and negative supply. पॉझिटिव्ह आणि निगेटिव्ह सप्लायच्या अक्रॉस मी काय करतोय, एक व्होल्टमीटर कनेक्ट करतोय. सो दिस इज द व्होल्टमीटर हॅव्हिंग अन रेंज 0 to 300. I am connecting this voltmeter across positive and negative. A positive terminal, this one is the negative terminal. त्याच्या अक्रॉस आपण काय करतोय, एक व्होल्टमीटर कनेक्ट करतोय. बघा connection. I have done the connection. Positive terminal of the supply, it can be connected to the one terminal of the ammeter. Ammeter च्या एका टर्मिनलला कनेक्ट केले. Now next terminal of the ammeter, it can be connected to the L terminal of the 3-point starter. F terminal of the 3-point starter, it is connected to the one terminal of the rheostat. Rheostat च्या एका टर्मिनलला कनेक्ट केले. Next terminal of the rheostat, it can be connected to the field terminal of the motor. Motor चे F terminal ला connect केले. Now A terminal of the 3-point starter, it can be connected to the A1 terminal of the motor, armature terminal of the motor. After that A2 F2 it get common. A2 आणि F2 दोन्ही काय केले, कॉमन घेतले, तो शॉर्ट सर्किट केले. And one terminal it can be taken, it is connected to negative, and across positive and negative we have connected one of the voltmeter. एक voltmeter connect केले across positive and negative. Okay, लक्षात आले का connection?
Yes, sir.
Okay. Now our connection is as per the circuit diagram. आपण जे काही कनेक्शन केलेलं आहे ते as per the circuit diagram आहे. After that just 1 minute. Okay, see, I will start our DC supply by using one of the rectifier unit. Okay, I have started. See, the mechanical loading arrangement of the motor is nothing but these are the drum of that machine. Machine चा rotating drum आहे, त्याला आपण belt through mechanical load arrange केले. So see, mechanical loading arrangement is there by varying this terminal or by rotating this wheel. We are applying the force on that drum. The drum वरती force apply करतोय. At that situation, this spring balance, it will show some of the reading in the kg. Okay, कशामध्ये reading आहे, दिसतायत का सगळ्यांना? kg मध्ये आहेत बघा. So this reading are in the kg 048. जसं जसं आपण force apply करत जाईल त्यावेळेस हे vary होईल. It will show some of the reading. Similarly, S2 is also shows some of the reading. हे vary झाल्यानंतर. So this is the spring balance when we are applying the load. ज्यावेळेस आपण load apply करतोय, by varying this we are applying the load. Right? So this is the mechanical loading arrangement किंवा mechanical load जो आहे, mechanical output of the machine जे आहे त्याला आपण direct load apply करतो. Direct त्याच्यावरती mechanical loading arrangement करतोय by using a belt and pulley or belt and drum arrangement. Okay, हे समजले का? हॅलो,
Yes,
रीडिंग
sir.
कशी घ्यायचे हे माहिती आहे ना तुम्हाला? सो वी विल स्टार्ट द मशीन नाउ. आपण आता मशीन स्टार्ट करूया. ओके, सी supply voltage. It can be shown by some of the it can be shown by voltmeter. Voltmeter ने voltage दाखवले किती voltage आहे, value of that voltage किती आहे. किती आहे, in between 80 and 100 there is, it shows that 90, but we have used connected it for 300, so it becomes 90 into 2, multiply by 2 करावं लागेल ना, किती येईल
180.
180. So 180 voltage आपण मशीनला दिलेलं आहे 180 volt voltage. Now by using 3-point starter, by varying a 3-point starter, we are just safely starting our DC shunt motor. 3-point starter vary करून मी काय करतोय, मोटर स्टार्ट करतोय. Okay. See, our motor start rotating. Motor rotate होते ना. Hello.
Yes, sir.
Our motor, it will be start rotating. Now at this voltage we will check the speed of the DC shunt motor. DC shunt motor का अपन speed check करो. See, किती आहे speed, 1467, right, 1466. Rated speed of the motor, it is 1500. By varying a reverse start, we are just increasing the speed. Reverse start vary करते मी. Okay, small value of reverse start I will vary to achieve the rated speed of the machine. Machine the rated speed achieve करते हैं. Okay, now the machine, it can be running on 1516 revolution per minute. Okay, that means motor, it is running on constant speed or the rated speed. Now at that position, check the voltage and check the current of the machine. Current taken by the motor and the supply voltage. Reading घ्या पहिलं. All of you take the first one reading. Voltage, it is equals to first one reading. किती आहे voltage? voltage किती आहे? $98 volt multiply by 2. किती होईल? 196. Right now, check the current at this position. 196 volt voltage आहे. आपण ज्यावेळेस आता फील्ड कॉन्स्टंट ठेवणार आहे आपण. So 196 voltage. At that situation, current is 2.52. 2.523 or 5. Okay. At that situation, we have not put the load. That means motor is running on no load condition. Then also motor takes some of the current from the supply. Why? Because काय reason आहे त्याचं? Because to overcome the no load losses. No load losses overcome करण्यासाठी motor takes some of the current. So no load losses in the sense the iron loss and core loss, that is eddy current and hysteresis losses, or frictional and windage losses. Okay. Now we are applying just load on that machine. Machine वरती आपण load apply करूया का? See the reading, first one. It is S1, spring balance S1. It is equals to 2 kg. Spring balance S2, it is equals to 1 kg. Right? Now we will check the speed. At that position, we will check the speed. (1525). Check the current. Current check kara. Supply voltage remains constant. Check the current, that is 3.355. 3.355, that means current increases. When load on the machine, it will be increases. Then the current taken from the supply, it will be increases. So this is the first one reading. Now see the reading of spring balance. So reading of spring balance, it is nothing but 4 kg. 4 kg varti ahe. And this one is near about, this one is near about to 3 kg. 3 kg ahe there. Now we will check the speed. (1515). Okay, or 1514 speed. Now check the current. 4.16. 4.16 घ्या इथपर्यंत. 4.16. 4.16 ampere. Now this is the second one reading. Now we will again increase the load. We will again increase the load on the machine. Motor का load अपन परत increase करूया. See the reading. See the reading. Here it is 7 kg. And here it is near about 5 kg. S1 is equal to 7 kg. S2 is equal to 5 kg. Check the speed. 1492. 1492. Check the current at this situation. 6.10 or 6.05 या 6.05. Now we will again increase the load on that machine. Again I have increased the load. See the reading of that load. Here it is 9 kg. S1 is equal to 9 kg. S2 it is equals to 6 kg. We will check the speed. 1477. 1477. Check the check the current. 7.39. 7.44. 7.4. Okay. We will take another one. Last one reading is that. Again we increase the current. S1 it is 12 kg. S1 12 kg आहे. S2 it is equals to S2 it is equals to 7 kg. Now we will check the speed. 1450. 1450. Now check the current reading, that is 9.8384. 9.83 yeah. 9.83. Okay. Now the reverse procedure is there. Remove the load on the machine. ओके, जी काय प्रोसिजर केली होती ते आपण रिव्हर्स प्रोसिजर करणार. आफ्टर दॅट स्विच ऑफ द MCB.
Hello. How many readings you have taken?
5.
Reading? 5 reading. Just 1 minute. I will leave from another one device.
सर व्होल्टेज कॉन्स्टंट ठेवायचं का?
हा, व्होल्टेज ऍक्च्युअली आपण काही चेंज करत नाही ना त्याच्यामध्ये. व्होल्टेज कॉन्स्टंट राहील. देयर इज नो चेंज इन द सप्लाय व्होल्टेज. जे पहिल्या रिडिंगचं व्होल्टेज असेल ते सेम राहील. Screen is visible to all?
Yes, sir.
Okay. See observation table. काय काय रिडिंग घेतलेत आपण? कोणते कोणते रिडिंग घेतलेत?
व्होल्टेज 196.
ओके. व्होल्टेज बघा. व्होल्टेज होतं आपलं 196. That is it remains constant. We have considered 196 volt. Okay. Now current at no load condition. No load condition चा करंट किती होता?
2.52.
2.52. Right. Second one, at that situation speed किती होतं? Actually we have
1525.
1525. लोड दिला होता का त्या कंडिशनला आपण?
2 kg.
Yes, sir.
लोडचं सांगताय का रिडिंग? नो लोडचं एक होतं ना, बट ऑल्सो इट विल टेक सम ऑफ द करंट. ठीक आहे. सो at that situation S1 is equals to 2 kg, S2 is equals to
1 kg.
1 kg. Okay. Now write the difference of this. या दोन्हीचा डिफरन्स इथं लिहायचा. That means the difference of this is nothing but 2 minus 1. S1 minus S2 is nothing but 1 is. According to this, use the formula and calculate the value of torque. Formula कोणता टॉर्क साठी? कोणता फॉर्म्युला टॉर्कचा?
S1 minus S2 into 9.81.
S1 minus S2 into 9.81 into radius of drum. आपण आता ड्रमची रेडियस चेक केलेली नाहीये. So the radius of drum it is equals to 17 centimeter. किती सेंटीमीटर?
17.
I think 8 2 16. 16.5 कुछ तो है स्केल. आई एम नॉट हैविंग अ स्केल नाउ. 16.5 सेंटीमीटर. 16 sorry 17.5 centimeter. Okay, I will write here so that you make the calculation easy. Okay, radius of drum, it is nothing but 17.5 centimeter. Now we want to convert this into meter. Meter मध्ये मला convert. This is not a radius, this is the diameter. ही जी काय आहे तो diameter आहे त्या ड्रमचा. Diameter of the drum, it is nothing but 17.5 centimeter. I want to convert it into meter. Also I want the value of radius. Radius ची व्हॅल्यू पाहिजे. किती येईल रेडियस याच्यावरून? रेडियस किती येईल? 17.5 divided by 2. It is nothing but radius, no? Diameter divided by 2. Hello. ड्रमचा जो डायमीटर आहे 17.5 सेंटीमीटर आहे, त्याची रेडियस किती येईल मग?
8.75.
राईट, दॅट इज 8.75 सेंटीमीटर. इट इज द रेडियस इज इक्वल्स टू रेडियस. ओके, now I want to convert this into meter. मला मीटर मध्ये कन्वर्ट करायचे. किती येईल व्हॅल्यू? रेडियसला मला मीटर मध्ये कन्वर्ट करायचंय. सेंटीमीटरचं कन्वर्जन मीटर मध्ये किती येतं?
uh, 8.75 into 10 raised to minus 2.
8.75, right? 8.75 into 10 raised to minus 3. So that is we can write आपण हे असं लिहू शकतो. 10 raised to minus 3 असतं का -2? Whether it is 10 raised to minus 3 or 10 raised to minus 2. सेंटीमीटरचं कन्वर्जन मला मीटर मध्ये करायचंय. मिलीमीटरचं कन्वर्जन मीटर मध्ये. मिलीमीटरला 10 raised to minus 3 असतं. सेंटीमीटर साठी किती असतं?
-2.
10 raised to minus 2 असतं. So that we can write radius of the drum 0.0875. It is in meter, right? 8.75 into 10 raised to minus 2, it is equals to 0.0875 meter. It is the radius of drum, it is in the meter. ही कॅल्क्युलेशन मध्ये यूज करायची टॉर्कच्या फॉर्म्युला मध्ये. S1 minus S2 म्हणजे 2 minus 1 येईल into if we want to convert it into Newton, that is Newton मध्ये कन्वर्ट करायचं आहे मला फोर्स. So I am multiplying here 9.81. Okay, 9.81. जर पहिल्याचं कॅल्क्युलेशन केलं तुम्ही, टॉर्क T is equals to torque T, it is equals to torque T it is equals to S1 minus S2, 2 minus 1, 2 minus 1 into 9.81 into 0.875. याचं जे काय आन्सर येईल तो टॉर्क येईल पहिल्या कंडिशनचा. ओके, वन्स वी हॅव कॅल्क्युलेटेड द टॉर्क, ज्यावेळेस तुम्ही टॉर्क कॅल्क्युलेट कराल, आफ्टर दॅट व्हॉट इज द कॅल्क्युलेशन? आउटपुट पॉवर. आउटपुट पॉवर कॅल्क्युलेट करायचे. व्हॉट इज द फॉर्म्युला फॉर कॅल्क्युलेटिंग आउटपुट पॉवर? दॅट इज 2 pi NT divided by 60. 2 pi NT divided by 60. 2 pi it is constant. N स्पीड जे आलेलं आहे त्या कंडिशनचं ते स्पीड. देन T इज नथिंग बट आपण कॅल्क्युलेट केलेला टॉर्क डिवाइड बाय 60 केले की तुम्हाला आउटपुट पॉवर मिळेल. राईट, वन्स वी हॅव कॅल्क्युलेटेड आउटपुट पॉवर, अगेन कॅल्क्युलेट इनपुट पॉवर. इनपुट पॉवर कॅल्क्युलेट करण्यासाठी फॉर्म्युला VL into IL. ओके, सो सप्लाय व्होल्टेज रिमेन्स सेम. जस्ट राईट हियर सप्लाय व्होल्टेज इनिशियली VL जे आहे ते लिहून घ्यायचं. सो VL इट इज इक्वल्स टू 196 होतं. त्या कंडिशनचा करंट आलेला जो काही करंट असेल आलेला जो काही करंट होता IL ची व्हॅल्यू suppose we have written here that is 2.52. याचं multiplication is nothing but input power. Output power formula वरून calculate होईल 2 pi nt divided by 60 वरून. Input power it will be calculated by 196 into 2.52. After that, efficiency it can be calculated that output power divided by input into 100. याच्यावरून efficiency calculate करता येईल. Okay, and after that all of you plot the graph of all these 5 reading. All 5 readings graph काय करायचं plot करायचं. Okay, getting, is there any doubt? कोणाला काय डाऊट आहे का याच्यामध्ये?
तर ग्राफ पेपरवर काढायचं का नोटबुक?
Whether you are having a graph paper, आहेत का तुमच्याकडं ग्राफ पेपर?
Yes, sir.
हा असतील तर एका ग्राफ वरती जर ऑल ग्राफ प्लॉट केले तरी चालेल. एका ग्राफ पेपर वरतीच तिन्ही ग्राफ किंवा सेपरेट ग्राफ पेपर असतील तर ग्राफ पेपर वरती ड्रॉ कर. ओके, ऑल ऑफ यू ड्रॉ दॅट ऑन ग्राफ पेपर. So you are easily point out the things, or easily point out that value. Okay, so all of you take the scale and plot a graph, and finally write the conclusion. What happened, whether the speed is decreases, whether the speed is increases when the load on the machine it will be increases. Machine चा load increase झाल्यानंतर speed decrease झालं का increase झालं? Decrease झालं असेल तर किती decrease झालं? Slightly झालं का greaterly decrease झालं? हे रिझल्ट लिहायचं परत. ओके, गेटिंग?
Yes, sir.
इज देअर एनी डाऊट? याच्यामध्ये कोणाला काही डाऊट आहे का?
नो सर.
ओके, if you have any doubt, then free to ask. All of you start writing manual and plot a reading, plot a graph also. Reading graph जे काय आहे as per instruction, all of you write this. Okay, so in this way we will conclude this today's practical, and we will stop here. Thank you.